First of all, it's an honor to be here and presenting in front of you all. I'm an artist and alumna of the University of Rochester, and I have been researching the use of three-dimensional reconstructions in preserving museum artifacts. In 2015, I joined Rolando Requeño of the Rochester Institute of Technology Center of Imaging Science and Ling Rao, one of my fellow alumna from Rochester, in a project to digitize select dioramas of Francis Glessner Lee's nutshell studies of unexplained deaths. I'm here to discuss our research into these dioramas as a case study of potential strengths and weaknesses of incorporating 3D reconstruction into heritage institutions. So to begin with, the nutshell studies are a collection of 19 dioramas depicting crime scenes based on actual crime scene photographs. They're currently housed in the Maryland office of the Chief Medical Examiner in Baltimore and are still used as a teaching tool for homicide detectives to hone their skills in the art and science of crime scene investigations. They were constructed in the 1940s by Frances Glessner Lee, daughter of industrialist John J. Glessner and Frances Macbeth Glessner. Lee's entry into legal medicine would not begin until the late 1930s through the friendship of Harvard medical student George Burgess McGrath. Through McGrath, Lee learned of the shortcomings present in 20th century homicide investigations, namely coroners often did not have enough medical training to adequately assess deaths, and as such, investigations often were botched, which, as you can imagine, is sort of a problem. The nutshell studies were created with the aim of developing an investigator's ability to observe the crime scene through specific methods and to construct a speculative narrative that would help explain the crime. So the reconstruction process began with collecting data in the form of photographs of the artifact. And here you can see the lovely Ling posing with one of the dioramas. For this project, we focus on three particular dioramas: the burnt cabin, three-room dwelling, and the barn. This data was processed through multiple programs to generate a point cloud that was derived from matches of corresponding 2D coordinates among the images. This point cloud was then triangulated to create a polygon mesh over which the texture of the diorama would be overlaid. In this process, we used three reconstruction programs ranging from open source to commercial in nature in order to test which software produced the highest quality reconstruction. Software tested included the open source program Visual SFM by Chang Wu, Recap 360 by Autodesk Incorporated, and Photoscan by Agisoft LLC. We determined the quality of reconstruction by using several variables, such as time required to render the reconstruction, number of facets, and the amount of manual editing required. Aspects such as user-friendliness were also used to determine subtleties in how each software may function differently given different applications. My role in this project was to focus on bringing the preliminary models into the open source graphics software Blender in order to manually remove extraneous data artifacts, as well as to patch over portions where insufficient data created holes in the model. And here we see the models in different stages of development. But why would we focus our efforts on digitizing these dioramas? Well, the nutshell studies face several issues that limit their effectiveness. Made in a scale of 1 inch to 1 foot, these dioramas are small in size, so the process of training investigators often involves crowding around the small dioramas, which, as you can imagine, is a less than optimal way to access such an important resource. The nutshell studies are also limited to a small audience of investigators and are not readily accessible outside the OCME office. Similar issues exist in other museum artifacts. Kimberly Bradley says the above quotation in her BBC article, Why Museums Hide Masterpieces Away, which you can't really see up there, but the Tate shows about 20% of its permanent collection, the Louvre shows about 8%, and she lists other statistics as well. While most museums have digital records of their collection in the form of photographs. These photographs often do not convey enough information for outside scholars interested in further research. 3D scanning allows for greater accessibility of the museum's collection, and that is